Hello, this is Ms. DB, and today we are going to learn about what to do now that you have two triangles congruent by one of the methods you learned about with SSS or SAS or ASA or HL. Now that you have them congruent, what more can we do with them after that? So it's called CPCTC. We used it a little bit before. It stands for corresponding parts of congruent triangles are congruent. So let's start with this little warm-up here. We're going to say if triangle ABC is congruent to triangle DEF, then what angle is A congruent to, and what side would BC be congruent to? So I would draw a sketch of this, and I'll call this ABC. And I know that that's going to be congruent to triangle D, so I put D in this bottom corner, E over here, and then F up here. And then it can become easy to see that angle A would be congruent to angle D. And side BC would be congruent to side EF. Okay, next one. What is the distance between these 2 points? You could graph them and use the Pythagorean theorem, or you could use the distance formula, which was derived from the Pythagorean theorem, which says to take the x-coordinates, subtract them, and square that. And to take the y-coordinates, subtract them, and square that. And if you do all that, you will get, I believe it says 17. No, the square root of 17 for an answer. Square root of 17. Okay, number 3. If angle 1 is congruent to angle 2, why is A, this line here, parallel to B? Remember that? These are alternate interior angles. So if they are congruent to each other, that means by the converse of the alternate interior angles theorem, the converse, it's very important that you say that, tells you then that the 2 lines would be parallel. And then the methods we've used to prove that 2 triangles are congruent so far are those down there: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg if you have a right triangle. You can use that sometimes. All right, our objective today is to use these initials in a row to prove parts of triangles are congruent. And our vocab is just that. So here's what it stands for. And it's in your book and it's on your worksheet for this lesson, so you don't have to memorize it, but when you use CPCTC, what you're really saying is the short way of saying corresponding parts of congruent triangles are congruent, which makes sense. If you have 2 congruent triangles, all of their corresponding parts are congruent. You can use that after you have proven that 2 triangles are congruent. Here's all of the ways that we use to prove that triangles are congruent. And then after you're done with that, then you can show that corresponding parts are congruent with CPCTC. So CPCTC is always used after you say that 2 triangles are congruent. So if you say 2 triangles are congruent by any of the methods that we've worked with, all of those different ones, then the next step would be to say that maybe an angle is congruent to an angle. Or maybe you would say that a side is congruent to another side. That's when you would use CPCTC, after you prove that the triangles are congruent. All right, here's a little example of this. It says that A and B are on the edges of a ravine, which is just like a steep cliff looking down. What is AB? What is the length of AB? So let's see. If we could somehow prove that these were congruent triangles, then I would know it would be a corresponding part to this other triangle over here that the length is given. So we have an angle pair that's congruent because they're vertical angles. We have this length being 10 and this length being 10, so they're congruent because their sides are equal. We also know that this length is 15 and this length is 15, so those are congruent. So by side, angle, side, the 2 triangles are congruent. So then I would say by CPCTC, the third side is also congruent, which means that this side over here is 18, so this side over here is also 18. That's how we use CPCTC. Okay, let's do a two-column proof here. We're going to put our statements here and our reasons, and if we get stuck, I put the flow chart on here so we could look and see what's next. All right, so we always start with our given. It says that line segment YW bisects XZ, this line here, and also that XY is congruent to YZ. So those are congruent. So I'm going to put that one first. XY is congruent to YZ. I want to prove that I have two congruent angles, angle XYW, XY. I want to prove that this angle is congruent to this angle. So my first step is to put down my givens. And my second step, I'm going to put the other given down. Now, what does it mean if a segment has been bisected? It means that that segment XZ, got cut into two congruent pieces. So from step 2, what follows is that XW is congruent to, I'll go ZW. And that's the definition of bisects. Okay. So now what do I have? I have this segment and this segment are congruent. I've got this segment and this segment are congruent. If I could have one more segment congruent, I would have that the two triangles, triangle 1 and triangle 2, were enough to be congruent to each other. What about YW and YW? They're the shared side. They're congruent because it's the same thing, and we call that the reflexive property. One side is congruent to itself. All right, so we've got the reflexive property, and now I've got a side to side, a side to a side, and a side to a side. Side, side, side. By side, 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 I can now say that triangle XYW is congruent to triangle XYW to ZYW. By side, side, side. Okay, now we get to use our new thing. By CPCTC, corresponding parts of congruent triangles are congruent. I can say that any of those corresponding parts are congruent. So I could say that angle X is congruent to angle Z, and I could say that this angle over here is congruent to this angle. And then finally, we're able to say the ones that we want up here, these two given angles. Angle XYW is congruent to angle ZYW. By corresponding parts of congruent triangles are congruent. And that's our proof. So we showed that the triangle was congruent, and then we showed that corresponding parts are congruent. Okay, this is another example. It's quite similar, except this time PR bisects angle QPS, so it's going to result in two congruent angles here. So when we do our proof, we're going to be using something besides side, 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 because we're going to be having some information about angles. So PR bisects, oh, it bisects both of those angles, angle QPS and angle QRS. So this angle is also bisected. So now we've got two congruent angles. We've got angle QPR is congruent to angle QPR SPR. And we've got angle QRP is congruent to angle SRP. These are both from definition of angle bisector. Both of these, same exact thing. These double quotes mean that you're saying the same thing again. All right. We also have a shared side. Shared side says PR is congruent to PR, reflexive property. Do we have enough? we've got an angle, side, and an angle. The side is between the two angles, so this is angle, side, angle, can tell us that we have two congruent triangles. Let's see, PQR is congruent to triangle PSR by angle, side, angle. And now we can use corresponding parts of congruent triangles are congruent to say that our side PQ, right here, is congruent to side PS. We could also say the other sides are congruent. QR would be congruent to SR. And we could say angle Q is congruent to angle S, but they only wanted us to have that this was what we wanted to prove. So these are not bad. Show that the triangles are congruent by angle, side, side, side angle, side, etc. And then use CPCTC. Okay, sometimes we use CPCTC and then we need another step after that to prove whatever it is they needed to prove. So sometimes we have to show that the triangles are congruent, and then we use CPCTC to show that some parts are congruent that we need, and then we're able to say, like in this one, with this one they want us to show that MN, right here, is parallel to OP. So if I could show that this triangle 1 is congruent to triangle 2, using the given information and stuff, and then I could use CPCTC to show like that this angle is congruent to this angle, then I could use like alternate interior angles, the converse of that, to show that these lines are parallel. All right, so let's see how to do this. Several steps for this one. First of all, we're going to put our givens down, of course, as we always do. And the given is that NO, I'm going to mark this, is parallel to MP, and also that angle N is congruent to angle P. Okay, got it. Next, because these are parallel lines cut by a transversal, I know that NOM, this angle, is congruent to this angle because they're alternate interior angles. Okay, what else do we have? We have a line that's congruent to itself. MO is congruent to MO. Okay, got it. Reflexive property. So now we have an angle and an angle and a side, which is enough to say that we have two congruent triangles by angle, angle, side. Well, once we know that we have two congruent triangles, we can say that all of their parts are congruent, and the part that I need is to say that NMO, this angle here, is congruent to this angle here. Because if those two angles are congruent, then by the converse of the alternate interior angles theorem, that means that these two lines are also parallel to each other. Whoops. And that's the proof of this. Okay, let's try this one. This one, we're given that we have a rectangle, and we want to prove that the diagonals of a rectangle are equal lengths. In other words, that FH, this diagonal, is equal to GI. So we'll start by filling in some given information. And then from that, because it is a rectangle, that means that FI is congruent to GH. It's already marked. Now it also means that FG is congruent to IH, but I don't need that to prove. What I want to do is take this triangle here and show that it is congruent to the other triangle up here. Because if I can show that those two congruent triangles are congruent, then I can show that their shared side is that diagonal is congruent to, oh wait, I drew the wrong triangle here. Let me erase that green line if I can. Nope. Okay, I picked the wrong two triangles. I wanted to do this triangle and this triangle. There we go. Those two triangles. So that's why I need FI is congruent to GH. That's one side. And now the right angle congruence theorem says that all right angles are congruent. So I know that FIH and GHI, I know that these are right triangles. So now I can say that that they're congruent to each other, because the right triangle congruence theorem says that all right triangles are congruent to each other. Okay, next thing that we're going to do is we're going to see if we have any other information. We have this side is congruent to this side. We have this angle is congruent to this angle. We know it's a right triangle because it's a right angle. So we also know that, let's see, oh, this side down here, IH is congruent to IH by the reflexive property. So I've got a side and then an angle and then a side. Side, angle, side. So by side, angle, side, I know that triangle FIH is congruent to triangle GHI. And then I can show that, sorry about that, I can show that by CPCTC, all the corresponding parts are congruent. So let's see. What do I need to show? I need to show that the third side, FH, is congruent to GI. They're congruent by CPCTC because they're both the third side of their triangles. And then that means that the length of FH is equal to the length of GI, which is the definition of congruent segments. So therefore, I have met what I wanted to prove, that the diagonals of a rectangle are equal lengths. And you could even say that. You could write that out too. And we have proved what we needed to prove. All right, great. Okay, in this example, we're going to try to prove that KL is parallel to MN. And to do that, we are going to start by putting down our given. Now this time we're using midpoint. Remember what midpoint is? Midpoint will break a segment up into two congruent parts. So KJ is congruent to MJ, and also NJ is congruent to LJ. So let's mark these over here. Congruent, congruent. Okay, we also are given not much else. All right, so we know that we have vertical angles. KJL is congruent to MJN. So these two angles are congruent. So we're really close to showing how these two triangles are congruent to each other. And we can do that because of side, angle, side. Side, angle, side, side, angle, side. So now we showed that we have two congruent triangles, which means all of their parts are congruent, including a part that we particularly wanted to look for, which is LKJ. LKJ is congruent to NMJ. These two angles are congruent to each other. Well, they're alternate interior angles if you're looking at these two lines. So the converse of the alternate interior angles theorem says that these two lines then must be parallel to each other. So there you go. We did lots of proofs. One last thing to look at in this section is you can do coordinate proofs. You can plot triangles in the coordinate plane, given the points that they give you, connect them, and then you can find the length of each of those segments using the distance formula. And here's that work. So they plugged in all of those points from this page. Where did it go? There. They plugged in the coordinates of the points into the distance formula. And when they did that, they found the lengths of all of those different segments. And you'll see some of them are the same. See? 2 times square root of 5, 2 times square root of 5. And here we have the square root of 5, square root of 5. And here we have square root of 13, square root of 13. Which means then, especially if you have it all on one page so you can look at it, it means that by side, 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 you have two congruent triangles, and therefore the angles that you wanted to show were congruent are congruent by CPCTC. It's a lot easier to do if you do it all on one page. So what they found by using the distance formula was that these two were the same, these two were the same, and these two were the same. So by side, 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 they knew that the two triangles were congruent, and then you're able to prove that DEF, which is here, is congruent to GH. I did the wrong angle here. DEF is up here, is congruent to GHI right here. All right, so you'll have one of those on your worksheet to use the distance formula for. All right, well, thank you very much, and I hope you have a good time doing these proofs. Remember to show that the triangles are congruent first, and then use CPCTC, and then if you need another step after that, which sometimes you do, then you go from there. Thank you very much, and let me know if you have any questions.